Hi friends, this is from on the way. Today I have taken another problem of leetcod 75, the most frequent last question. The question given is delete the middle node of a linked list. Okay. You are given the head of the linked list and delete the middle node and return head of the modified linked list. So you can check out the question. Here the linked list is given 1, 2, 3, 4, 5, 6, 7 and the middle node is 7 that is deleted. And this is the modified linked list. Okay. And for this is 0 1 2 3. Okay, 3. Okay, this is taking like 1 2 3 4 4 by 2. What is that? 2. So 0 1 2, it is taking 0 vex indexing for n equal to like the size of the linked list. Okay, for the code part you must know the very famous algorithm, fluid cycle detection algorithm. So by that algorithm let me solve this question. For that, let's take list node first pointer pointing towards head. Okay, and list node slow pointer that is pointing towards head. And as we have to delete the middle node, so let me traverse it simultaneously. Let me traverse previous node because we have to delete that node also. And at first it is pointing towards node. We will traverse till first not equal to null, and for not being face the runtime error, let take first next is not equal to null true. Okay, so at that time by the fluid algorithm you maybe know, or let me tell you. For this fluid algorithm you have to take two pointer from starting. You have to take two pointer, and one pointer you have to you have to step it two step at a time, and at the simultaneously at the same time you have to take slow pointer or another pointer one step, so that when you will reach the last pointer, the two step pointer, when it reach to the last pointer, at the same time the one pointer one step move pointer that will reach the middle point. Okay, so by this we will move first to two step, first equal to first, next to next, and simultaneously let's make previous equal to slow, and slow to move one step, slow equal to slow next. Okay, when when this first pointer is not equal to null or first next is not equal to null, by that time it will reach the last point, last node, and at the same time it slow will reach the middle node, and what previous node that will be reach the previous node of the slow node. So if the slow node will point to after the while loop, after the while loop, mm, after the while loop termination, when the first pointer will reach the last node, at the same time the slow pointer will reach the middle node, and the previous node that will reach the previous node of the slow node. So that will be point to 4 in this example. So if you will take, if previous is not equal to null, then what we will do? We will do previous next equal to slow next. We will point this previous, for this example this previous ka next is equal to slow next. That means this 7 that will be eliminated. Okay, and we will delete slow, and what we have to return? We have to return the modified list. So it will be head. Let me run the code. Yeah, you can see this is accepted. Let's submit it. Okay, okay. If let's take a base case. If head equal to null or head next equal to, yeah, it is accepted. You have to take the one base case because when there will be only one pointer or there is no pointer, we cannot find any middle node, so we cannot delete it. At that time we have to return null. Okay, and what will be the time and space complexity for this code? The time complexity, you can see the this is while loop is traversing one time, so the time complexity will be big of n, and the n means the size of the or the number of nodes that present in the linked list. And what will be the space complexity? Is there is no extra space we are using. These fast and slow previous, this all are used. Is we are not using any extra space, so the space complexity will be big of 1 constant space complexity. Okay, let's say next question. Thank you.